Hello everyone, so welcome back to my channel and let's start with today's Leetcode daily challenge, and this is minimum number of swaps to make the string balance. Okay, so from today onwards I will be making videos on all the Leetcode daily challenges going forward, and we'll be completing that Leetcode 75 playlist together. And so let's start today's question. So we are given a zero index string s of even length n, and the string consists of exactly n by 2 opening brackets and n by 2 closing brackets. Okay, and a string is called balanced if and only if it is an empty string, or it can be written as AB where A and B are balanced strings, or it can be written as C where C is a balanced string. Okay, and you can swap the brackets at any two indices any number of times, and we have to return the minimum number of swaps to make S balanced. Okay, so let's just read the example. So this is S, and we have this closing bracket, then open, then closing, and then closing. So this part of the string is balanced, so only these two are unbalanced. If we swap them, we will get the balanced string as this one. Okay, so only one swap is required. Okay, and the second example is 3 closing, then 3 open. So if we swap the first one and the last one, and the second one and the second last one, then we get our basically balanced string. So two swaps are needed, and in this is a balance, so we do not need any swapping, right? Okay, so let's just try to build our logic and what is the logic behind that intuition. Okay, so we have this minimum swaps, and this is our input, this is for second input. So how it is that we have done in the example, if we swap this and this, you see, so it will become this, then this and this. So this is balanced because for every opening there's a closing. This is balanced, and this is for this opening we have a close, so this is balanced. Number of swaps is 1, so our answer is 1. Okay, and this is closing, 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 then it is open, 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 right? So how we will get the like balance string? If we first need to balance in pairs, if we try to do that, so first we will balance these two in the middle, right? So this will be like this, and if we swap this one and this one, okay, so this will be here, this is same. Okay, so I will write the same ones, this is same, this, okay, this is same, this is same, and this is also same, the swap we have done, so I will write it with different pen. Yeah, and now we did not do anything for this right now. Okay, so first swap will be like this. Now we have number of balanced pair is 1, 2. The only thing that is unbalanced is this, so now we'll do this one with this one, so it will be this. Now the balance string is this, and we did this, so second swap is this. So first swap was this one and this one, second one and this is fifth one, after that first one and sixth one, right? 1 6 2 5, so two swaps are required to make it a balanced string. So let's just check like how we will do this. Now we know that the number of open brackets is n by 2, and closing brackets are also n by 2, right? So if we say we have a string length of 2, n 2, so we will have one opening and one closing. It can be this or it can be this, right? This is balanced and this is not balanced, so in this case we will need one swap. Okay, so how we will check if this is balanced or not? If we can first check that we have encountered a opening bracket. Okay, we have opening, we will store it in some space. Okay, now moving forward we will check if we require any, if we encounter any closing that will like get this pair with this, we can say that this has made the pair, right? So how it is, like we have this. First we come to this closing. We will check if we have any opening bracket in our storage to pair with this. So initially we don't have, okay, so we will not do anything, but we will come to this, and since it is open, we will store in it some space, right? Now when we go out of this, we will not have anything here, so we'll check. Since our storage has one opening bracket which could not have paired with any closing bracket, right, during our iteration, okay, during iteration. So that means that we need some swapping, that there is some closing bracket in that string which came before this opening, okay. So that means how many swaps we require. Since the size is 1, we only need one swap, okay, which will make it a balance. Okay, let's just take a bigger example. N is 6. Now we will take an example, 3 closing and 3 opening, right? So as we checked in this our example, this is answer is 2. So we will store it somewhere, right? Check if we are going correct. Now first we come to this. We have this storage, okay. Since it is a closing bracket, we don't have to do anything because it cannot, we don't have any open bracket to pair it with. So we will move forward. Again, since it is closing, we don't have to do anything, we will move forward, okay. Now we have come to open bracket. For open bracket, what we have to do, we have to store it in our storage, okay. Now we move forward. This is again opening, we will store it in our storage. Now again opening, we will store it in our storage. Now we go out of this string. Now what we have, we have this storage which have three, basically three open brackets, okay. Open bracket storage, this is called. So what we now have to check, since all are open and we have not encountered any closing bracket to pair with these, so that means that all the closing brackets have came before all of them, okay, because we cannot pair with them. So now we check, since this is size 3, the size is 3, okay. So how many swaps we will require? As we have discussed, if we swap these two, we will balance these two pairs, and if we do this swap, the whole string is balanced. So 2, and how we can do that? Since this is 3, if we do swap for this, okay, so it will balance with 1, it will balance 2 pairs as we have discussed. Since if anything we can take, okay, these how many size? 4, right? If we do this swapping, it will be like this, and with this one swap, the whole string is balanced. If we take a size of 4, okay, let's just say this and this, okay, first all are closed, then all are open. How many swaps do we require to make it a balance? If we swap these two, right, so it will be like this and this. So for 4 size of this, all are like unbalanced, we only require one swap to make it 2, okay. So one swap balances 2 pairs. So this is like logic that we have encountered from all of the examples. So for this, we have, like, if we do one swap, so these two will be balanced, okay, and this one will be left. So how will, so for this one swap is required. So what we have checked, for 3 size we require 2, and for 4 size, if we say, we will also require 2 as we have discussed. So let's just take the size 4 example. So we have 4 closing and 4 open, Okay, so how we'll get balanced? Okay, first we swap these two. Okay, now what we'll get? We will get this 1 2 3 4. So this will come here, this will come here. Okay, these two are swap. Again, if we swap these two, the outer ones, we will get this one here and this one here, and this one was similar to above, this one was similar to above. So how many swaps are required? Two. Okay, and let's do that storage thing again for this. Okay, so the answer that we have got, two swaps. Okay, now let's just go for that storage method. We come to this closing, we will not do anything. Again we come to this closing, we will not do anything. We will go until we come to a opening. So this is opening, we will store it in our storage. Okay, again we encounter opening, we do not have any closing that will pair it, so we will add it in our storage. Again we come to an opening, we will store it in our storage. Again we come to an opening, we will store it in our storage. Right, now we have come out of this string balance. Okay, so we have this size 4, and how many swaps do we require now? That we have done above, 2. So from this, how we will get to? So 4 divided by 2 is 2, right? But for 3 also we require 2. So for 3, how do we get to? 3 plus 1 divided by 2, right? So if it is an odd value, we have to add, and if it is an even value, we have to just divide by 2. Or what we can do for both of this, since we are doing an integer division, 3 by 2 will give a 1, but 3 plus 1 by 2 will give us 2. So I will do that math later, but the logic for this string balance, are we clear on that? Okay, for open brackets, we only need to do some operation. Okay, so since we are just using this, and most of the balancing operation related questions, okay, require stack. I did not set this at the starting of the question, because whenever we get into interviews, we do not know that it is a stack, queue, or any other data structure question. So we have to build this logic, because what we have to do for every open, we have to like check for close. So we need to store this open, and whenever we encounter close, we have to remove this to get the basically storage. So what we have to do again, if we take another example, that will do pop operation also for stack. So let's just take another example. So we have a string size, this 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 and open and then open. Okay, now if we check 1 2 3 and 1 2 3, so we have the required string. Now we have to balance it. How many swaps are required? If we check, this is closed and this is open, this is open, this is balanced. Okay, so how many swaps? This is balanced, we do not have to do anything. Now the string that comes into play is this part only, and we know for this, if we swap this one, so we will get our answer. Okay, so for balance we don't need anything, right? Only unbalanced string part we have to do. So only one swap is required for this whole string. So let's just do that our storage method using our stack. Okay, so we have this stack. What we'll do, we will come to this. Okay, it is closed, we do not need, because we don't have any open bracket to like pair with this. So we will go forward. Again we close, no open, will not do pairing. Now open bracket we encounter, we will add it in our storage. Okay, now we encounter a close. Whenever we encounter close, we will check if there is an open bracket in the stack. There is open bracket in the stack, what will do, it will pair, so we will remove it. Okay, because it will pair and it will balance the string. Now we come to this is open, there is no closing, that there is no storage, so we'll add it in our this. Now again open, again store in our string, storage, this is tag. Okay, so now we have two size tag, right? One we have already paired, two we have left. So how many pair swaps we require? 2 divided by 2, that is 1, that we have encountered previously tried, and if we swap these two we will get the balance string, right? So this is a logic that we will use to solve this question. Okay, so time complexity in this will be big of n only, right? Since we are just iterating over this and inserting the stack. Okay, and space will be big of n by 2, since most of worst case what will get, this one and this one. Okay, the size is 8, and as we have gotten the question, n by 2 will be open and n by 2 will be closed, and we are storing only open brackets in our storage, so the storage will be big of n by 2, right? So yeah, we will also optimize this while doing coding part only. So what we can optimize, I will just tell you, and you can also try it on your own. Basically, since we are just doing part for this open bracket, why should we use this tag? Okay, we are doing this open bracket, and whenever we encounter a close, we will check for the open bracket count, right? So we can use it like using variable only. We don't need that stack, and due for that the time complexity will be same, but the space complexity will be big of 1, right? So we will do it during coding part, but you can also try it, pause the video and try it on your own to better understand it, right? So let's just move to the coding part. So yeah, so what we'll do, we will create a stack first. Okay, this is a storage. Right now we will go for each character in this string. Okay, for each character, what we'll do, if this character is open. Okay, now what we have to do, we just have to insert in our stack, so add it in our stack. Okay, so we'll take it characters type. Right now, since if it will not be open, it will be closed. Now what we have to do, we just have to check if stack dot size is greater than 0. Okay, that means there is an open bracket in our storage, so we have to remove that to pair it with this closing, right? So store encountered closing bracket. Okay, so if this, remove the open from the storage to pair it with this closing. Okay, so yeah, okay, I think now it will be visible, right? So what we do, stack dot pop. Okay, we only need to pair one because we have encountered only one, right? Now whenever we come out of this loop, what we have to check for the stack dot size, right? So we will check stack dot size. If it is divisible by 2, how we will check? If it is divisible by 2, then we just return by 2. Okay, and if it is odd number, then we just add, right, and then divide by 2. Okay, so let's just try to submit it. Okay, we have this. Let's just change this to st. Okay, it is, yeah, it is successfully submitted. Okay, so now what comes that part when we try to optimize it. Okay, so if you have tried it on your own, so let's just try to do that. So what we'll do, we basically need that size. Okay, here also we need the size. What we'll do, we will have one size. Okay, or we can say open bracket count. That will make more sense. So whenever we encounter this, what we'll do, we will update the open bracket size count, right? Number of open brackets. So now whenever we encounter a closing bracket, we have to check if there is any open bracket. So what we'll do, we will check if open bracket we have more than one, more than zero. Yes, so we will pair it, so we will subtract it. Okay, one by. So now, so again same thing, the latest size of the open bracket count, that will do our operation. So we'll replace it. Okay, so it is working fine. Let's just try to submit it. Yeah, it is successfully submitted. Yeah, thanks everyone for watching. In case you do like this video, please do hit that subscribe button and like it. And in case you have any questions or any doubts, please do ask in the comment section. I will try to answer all of them. And in case you have any suggestions, yeah, you can also share that. I will work on them. Thanks everyone.